Question 7 is coming from Trigonometry Part A. By first obtaining a quadratic equation in cos theta, solve the equation, this one here, for theta ranging from 0 to 360. Now, we have tan theta, sine theta is equal to 1. We know that tan theta is the same as sine theta out of the cosine of theta. Now again, this one we multiply it by sine theta. If we cross multiply here, of course sine times sine, that is sine squared theta, which is equal to the cosine of theta. So since this one is not squared, that simply implies that we write sine squared theta in terms of cos squared theta. So that would be 1 minus cos squared theta, which is equal to the cos of theta. If I take everything this side, we shall have cos squared theta becoming positive. It finds the cos theta, which is already positive. When one crosses, it's a minus, and is equal to 0. This is a quadratic in cosine of theta. So they say a quadratic equation in cosine of theta. You see that? Then we solve this one. Since it cannot be factorized, we can use the quadratic formula. So cos theta is equal to negative b minus b plus or minus to the root of b squared minus 4ac out of 2a. You need to do this one to show the examiner that you are attempting to solve the quadratic equation. Don't just put this one in your calculator and then you write down the answer. You lose a mark. Okay? So cosine of theta can either be negative 1 plus, this will be of course a positive, then positive 4 plus 1, that will be a 5 root of 5 over 2, or cosine of theta here is going to be equal to negative 1 minus root of 5 over 2. Okay, but this one here is going to be bigger than 1, and cosine ranges from negative 1 to positive 1. So we cannot get a solution for numbers that are below negative 1 or that are greater than 1. Let's check it out. Negative 1 minus root of 5, then divide by 2. You see this one is below negative 1, so we cannot get a solution there. If I say shift, then mod, then I put it in degrees, and then I come here and I say the arc cos of this, the calculator will give me math error. You see, because it goes beyond negative 1. So, therefore, I just write here, this one is undefined. You forget about it, and then you come to this one. So, theta is going to be equal to the arc cosine of negative 1, then plus root of 5 out of 2. Now, for this one, I always use this circle here. If you have been following me, you must have seen me drawing this every now and then. So for the 4 quadrants, all of them are positive. Sine, cos, and tan are positive in the first quadrant. Only sine positive here, only tan is positive here, and only cosine is positive here. So 0, then when we go anti-clockwise, the angles are positive. So this will be 90 degrees, this will be 180 degrees, this will be 270 degrees. By the time you come back here, this is 360 degrees. And of course, when you go clockwise, the angles are negative. Now, if I project an angle theta here and also this other side, because opposite angles are equal, then the same thing, I do it here. This is theta, and also here, that is theta. Then to move from here up to here, it's like getting this whole of it, which is 180, then subtract this theta here. Okay, so meaning this one is going to be 180 degrees minus theta to get the angle in the second quadrant. And then this one will be 180 plus theta. This one will be 360 minus theta. We look at the deviation from the horizontal axis. Okay, so that's why we are using the 360, the 180, like that. So why do we say 360 minus theta? Because we are moving from here up to here. So already from here up to here is 360, then minus this one. That is why you have this. Okay, so that is that. Now, this one has to be a positive. So when I come here and I take off this, first of all, this one has to be positive. So you see, it's a positive. Now, I'll press Shift, then cos. That one is giving us 51.8 to 1 decimal place. 51.8, that is to 1 decimal place. You have to be so careful here. You have to look at the domain given. If it is in degrees, then your calculator must be in degrees. If it is in radians, then let your calculator be in radians. Okay. Now, because this one is positive, we are supposed to go to another quadrant where cosine is positive, which is here in the fourth quadrant. And to get an angle in the fourth quadrant, we say 360, then minus the theta, the acute angle you have gotten here. Okay. So minus 51.8. So meaning that our theta is going to be equal to 51.8. And then when we subtract from 360, what do we get? So I will come here and I say 360 minus this, which is 308.2. 308.2 degrees. All of these ones are to 1 decimal place. So these will be our answers here. Part B, show that this one is equal to this. So I'm going to begin. You can begin with the right side to prove the left, or you can begin from the left to prove the right side. So I'm going to start with the left side. Tan theta out of sine of theta minus sine theta out of the tan of theta. This one, using the rules of fractions, I need to first I'm going to simplify, okay? Then I go to the rules of fractions. So tan is sine theta over cos of theta, but here there is over sine, so I'll just say times 1 over sine theta, okay? This one here. Then minus, this one is going to be sine theta over 1. Then this is sine over cosine. I will say maybe times cosine over sine, but I'm going to write it as sine theta over cosine of theta. Okay, but you should know that this is the same as, of course, this one will go. Then we shall have 1 over cosine of theta. Then minus, this will be sine theta over 1. Then times the reciprocal of this one, it will be cosine of theta out of sine of theta. This one will go. And then we shall have 1 over cosine of theta, then minus the cosine of theta. The LCM of cos theta and 1 is cos theta. So I'll have cosine of theta, then divide by the cosine of theta, you will get a 1, then minus cos theta, divide by 1, you get cos theta, then times cos theta, you will get cos squared theta. This one here is the same as sine squared theta, then over cosine of theta. Now, sine squared theta is the same as saying sine theta times sine theta. Now, down here we have cosine of theta. So sine theta over cosine of theta is the same as tan theta. And then we are remaining with the sine theta there. And this is what they have told us to prove. If you can check right up here, tan theta, sine theta.